So yeah, so let me see. Kavya actually put something in the chat here about harnesses. I think agent harnesses are like the orchestrating parts on top of large language models to get the work done in a certain way. So yeah, it's actually it's reminiscent of the reasoning models as well, where you have these things that are sort of on top of the large language model output, and then that helps you refine the content that you actually use from the model. And I guess like a harness would be like supporting materials. I'm trying to think of how you might write a harness, say, for some application. So it's like a neurosymbolic maybe piece that you put on top instead of just having like the standard LLM. Uh, yeah. So that would be
The
something that would be built on top of it, or after the output, or in inside the architecture. How would you go about doing
this is the this is what so we had the Ralph Loop uh, developer actually come
that?
and speak at the tower,
Okay.
and so unfortunately, his term Ralph Loop is now so ubiquitous that I can't I can't find the actual guy anymore. It's just people talking about Ralph Loops.
Yeah.
Um, but some of that was what he was trying to get at, which is um, it talks a lot about memory and context um, and the like the reasons he's calling it Ralph is that it doesn't need to be smart. It just needs to be. It just needs to keep trying.
Okay.
Um, you know, and uh, yeah, yeah. But I think so. This is okay. Okay. Definitely check that.
Yeah.
Yeah,
This is
yeah.
the another repo that got famous. This is the ponytail. Yeah. So this is well, ponytail.
Okay.
It's like comic book guy and Ralph Wiggum basically. He says nothing. He writes one line. It works. And
Yeah. He should be able to replace you with a short
small
shell
shell
script.
script. Yes. Yeah, that's it. And then, yeah, so it's like one line of code or a very small thing that you would use to, or I don't.
But it's just a plugin. Like no, I haven't used it much, but means I haven't tried it yet. But from what I could see or get to know about it, it's like normally when you tell an LLM to write some code, it gives you a whole pile of code together. So there's also some redundancy or some irrelevant chunks that are there in the code. So Ponytail basically reiterates through that and only writes the code that is just necessary. So shortening the output code.
Okay.
So
That's yeah, yeah.
uh,
That's something again that you you sometimes really want. It's like you get some working code and then you're like, okay, now make this like a quarter of the size. Make this much more efficient.
Yeah, yeah.
But then you have to stop it where it's like, but also keep it, readable or like it's
Yeah, we talked about sustainable shell scripting at one time. You were talking about that actually, and is that a very
yeah.
similar concept or?
Well, it's the same. It's a similar, it's a similar tension that you have in coding, right? Where it's just like you want you want sufficiently complex, but not overly, right? You want you want to capture like all the particular failure modes, and you want to make sure you got all the the edge cases, but you want to also keep it readable, and keep the set logic readable, right?
Right.
Like these are these are great tensions. Good. And then you potentially have the issue of you want to keep the code fast, so like how is that being dealt with, or um, um, um,
Yeah. Actually, it allows me to transition to something I want to talk about here. So we did have this discussion about shell script sustainability, and this is an article on what is a shell script in Linux. And so this is where you're using scripts to automate repetitive tasks, and usually this is a term they use in Linux for this. So in Linux, you're using the command line a lot, and you're automating things. You can do this in Slack as well. You can create a Slack bot, or you can do other things in a similar way, or like with what we were just talking about with harnesses. So a shell script in Linux is the idea is to boost efficiency and productivity. It also allows us to streamline complex workflows and ensure consistent execution of commands. So this is a tutorial that I pulled up that just kind of goes over shell scripts. So a lot of times you'll use this in programming projects. You might also use this in open source communities as a way to automate tasks that a lot of people might have to do repetitively, or sort of rote tasks that need to be done, but you don't want to devote human resources to it. So we talk about the shell. Systems admin people can utilize the shell as a user interface to access the services provided by the operating system. So the shell not only interprets the commands entered by the administrator, but also executes them. And then, of course, you can use bash or sh or csh or ksh or zsh as different types of shells. And so then you have these shell scripts, which allow for automation, efficiency, customization, portability, and development. And then it just kind of shows how you execute a shell script. And then, of course, there are these different concepts in shell script, which is where you have things like shebang, which is a way to, specify the path to the interpreter. And then we have comments. So the shell discards comments during execution. So you might make a comment in your shell script and it automatically disregards those. Then you have variables, so you can have different things that are accessible throughout the script, like names or other things. You have control structures, which then are like these if-else statements. And so this is very much like a very rudimentary programming language, but just for the command line. And so the idea of sustainability, though, comes from if you have a lot of shell scripts and you need to have best practices across your organization, how do you manage that? So this is an article on sustainable coding best practices for shell scripting. And then the subtitle here is Discover Sustainable Coding Practices for Reusability in Shell Scripting, Enhancing Efficiency and Maintainability in Your Projects. So this is where they talk about the importance of maintaining efficient code and how that should be a prime imperative. As software projects grow, the demand for tools that facilitate easier updates and modifications continue to rise. Writing scripts that retain their usefulness over time is crucial. This not only saves valuable resources, but also fosters collaboration among developers. And so one of the things that, again, we talked about sustainable programming earlier. That's something we covered in the open source meeting, and so it is with shell scripts. So one key aspect of creating lasting scripts is the emphasis on modular design. Modular components allow for easier testing and implementation of changes. Furthermore, this approach leads to improved readability, making it simpler for others to understand the underlying logic. When developers prioritize creating small, reusable functions, they inherently boost the efficiency of their work. And so we just need to anticipate future needs and manage our shell scripts appropriately. So, but it's also about maintaining practice within the organization. So if you can maintain the development of good, effective shell scripts and making sure that everyone knows where they are and how to write have a consistent method for writing shell scripts, then that helps you out. So this is where we want to minimize technical debt and enable rapid adaptation into requirements. But we can't do that if our method for creating shell scripts is such that there are no standards, and then we spend time having to debug those. And then, of course, adding proper documentation is essential, and not only its future developers, but also enhances the usability of scripts. Maintaining clarity in code contributes to better maintenance and understanding. And then, being able to take modular scripts or these scripts that have some structure to them is a way to enhance efficiency. So breaking down complex tasks into smaller manageable units can significantly boost productivity. The approach not only simplifies maintenance, but also enhances the clarity of the overall process. Each component can be developed, tested, and debugged independently, which leads to a more streamlined workflow. As well, modular scripts allow for easier collaboration among team members, as individuals can work on different modules simultaneously without stepping on each other's toes. So a recent survey indicated that 70% of developers prefer modular approaches due to their flexibility and ease of understanding. So and then they illustrate this with a scenario where a script for file backup needs enhancement. Instead of rewriting the entire script, you can simply update the backup module. This way you retain the integrity of the original functionality while incorporating new features. Okay, so I think that's, kind of a nice discussion about thinking about these kinds of tools that we use for programming and how we manage them in our organizations. This is Morgan, but Yummy Melon. This is
well, it's just I was thinking about how how I got started with shell script, and how how utterly life changing it is. Yeah. And and it makes me think about again, it just being a bit of a student of the history of science and computer science and coding as well. That there was the what's it called, the Hacker Manifesto. Was it Eric Raymond?
Yeah, I think so.
Anyway,
yeah.
But, and yeah, so it's just like everything you're saying about shell scripts is like so important, and so like if you've come to computing from Windows or Mac OS, right? Like it can be you've only used a mobile phone or an iPad, like a tablet or something, right? Where it's like even more kind of limiting. Like the wonderful lessons that are in shell script for how to write processes and the design constraints that they used to allow for all their tools to be interoperable, so that I mean, again, from a kind of like coding sustainability, there's just like so many wonderful lessons in Unix about how to do, how to settle that tension in coding, right?
Yeah.
About like making tools readable, making tools, single purpose, but making them always interoperable with a common interface, right? Like, and anyway, and then it just kind of got me thinking about, the coding today, with agentic coding allowing this kind of like personalized code, right? Where you can almost generate code to do your task, as opposed to relying on other people's code, right?
Yeah.
And some of what like so Emacs and Eric Raymond's big thing in that particular manifesto was that like you need to study Lisp just because it's conceptually such a different kind of programming language.
Yeah.
But that it's just super interesting that it's also the basis of this editor that absolutely can be, that is customized, endlessly. So without getting into debates about Phi versus Emacs, but if we just look at it as kind of like an early conception of this, where it's just like you absolutely built your own interface, because it's like you tailored it to your workflow, your tasks, your things like that, right?
Yeah.
Anyway, it's like, so I've just been playing with using LLMs together with Doom Emacs, to see, what kind of synergy you can find there.
Yeah. Yeah.
So,
It's a good topic. We should come
okay.
back to it. Yeah.
Yeah. So I've got another project called Autonomic, which is is like putting the Tau agent harness in Doom Emacs, and
Okay.
so it's somewhat it's actually it's supposed to be a strange loop.
Right.
Because you're actually, it's like you're putting it in Emacs so that you can understand Tau, but you're then using Tau to help you with your Emacs configuration and like help you with your Emacs programming.
Yeah.
Yeah.
Yeah. Well, that's great. Thank you. All right, I'm going to finish up with an article here. This is actually, let's see.